Today I will be speaking on heavy metal ion sensors. In fact, for heavy metal ion sensor, there could be a number of combinations you can use and develop these sensors. But as far as this particular talk is concerned, I will be focusing on combination of composite of organic conducting polymers and carbon nanotubes. Even in my center, we are exploring many other materials like graphene, single walled carbon nanotube, metal organic framework, metal or metal oxides, porphyrin, phthalocyanine. We are exploring many other materials for various sensor applications. But today I will be giving you brief overview of what kind of advantage we will be having if you are having composite of carbon nanotube with organic conducting polymer, and that too a heavy metal ion sensor. This is going to be outline of my talk today. I will be briefly introducing my center, Russa Center for Advanced Sensor Technology, and one of the reasons for that is I'm sure across this, it's not only Maharashtra, but across the country, most of the affiliated colleges and even state universities, we are having shortage of state-of-the-art facilities, and faculty members, particularly young faculty members and research scholars, they are really struggling to get access to those state-of-the-art facilities. Fortunately, with the substantial funding from various funding agencies, we could develop a very wonderful facilities for material synthesis, characterization, and device fabrications at Russa Center at my university. So I thought, let me introduce you my center, and then I will be giving you a brief introduction of water pollution and heavy metal ion sensing, and then I will be giving you the overview of what kind of work we are doing, and then of course the conventional approach and new approach which we have adopted, we started adopting since last almost 1 year. We got good results also, and then I will be summarizing. To begin with, let me introduce my center. This is the building of Russa Center for Advanced Sensor Technology at Dr. Babasaheb Ambedkar Marathwada University, which was established in the year 2016. This is in fact the offshoot of Department of Physics, because I'm getting my bread and butter from Department of Physics, and this is still extension of Department of Physics. But since the RUSA has given us substantial funding, and then whatever the infrastructure I have procured through various funding agencies, that I have transferred the entire infrastructure, all those equipments under one roof, and as a result of that, this has become a wonderful common facility center with state-of-the-art facilities, as I mentioned earlier, in the area of material synthesis, characterization, and device fabrication. One of the beauty of this center is these facilities can be used by anybody across the country. And since last 4 to 5 years, we have initiated almost 40 to 50 collaborative proposals from affiliated colleges and state universities. And we always ensure that whenever somebody is utilizing our facilities, he or she should come up with at least 1 or 2 scope of publication. All those 40, 50 collaborators got 1 or 2 scopes of publication during when they were having association with us. This is the entrance view of my center. As far as the theme sectors are concerned, we are, as I mentioned earlier, we have got wonderful facilities for material synthesis. We are synthesizing various materials that I have mentioned already earlier, and we are using those materials for 3 different applications like VOC sensors, heavy metal ion sensors, and some biological sensors as well. And moreover, we believe that only laboratory research is not going to serve the purpose. We need to go beyond, and laboratory research should be converted to product. And therefore, we are focusing on developing some handheld sensing gadgets as well, and we have come up with good number of gadgets also. There is one group from computer science who is associated with our center, and they are working on remote sensing applications. As far as the SMT integration is concerned, we focus on basic research as well as application. I mean, the fundamental research, we always encourage fundamental research, and we always ensure that the fundamental research is being converted into one or other application. And since we are, because I am also heading one of the another department center in the university, Dindayal Upadhyay Kaushal Kendra, wherein we have got BHOK and MHOK courses running since 2013. As a result of that, we have got connected almost 50 to 60 industries in and around Aurangabad. And as a result of that, we are helping all our collaborators to transfer their technology if you are having the prototype devices. As far as the capacity building is concerned, because we believe that it's not only promoting teachers, but we should we should encourage students, undergraduate student, postgraduate student, and research scholar. So there are many programs we are organizing very regularly in the center to enhance their capacity, and I'm going to tell you what kind of program we are organizing in due course of time. As far as facilities is concerned, this is the list of facilities which we are having for material synthesis. You can see here, this is the list. I'm not going to read the list because I have 40 stipulated minutes, so I need to complete everything within the stipulated time. So this is a list of material characterization, equipment for material characterization, and then device fabrication as well. And this is, I was talking about this VIS NIR hyperspectral imaging spectrophotometer, which is being used by one of the computer group, one of the group from computer science department, and they are working on surface vegetation. Let me quickly show you the pictures of the facilities. Like this is the process laboratory which we have developed in the center, because since mainly we are working on very hazardous chemicals, like all the polymers which we are talking about, those polymers are very hazardous and carcinogenic in nature also, right? So we need to take care of the health of our research scholar or those who will be working in the lab. So we need to maintain that kind of environment in the lab. And then a process laboratory, this is another view of process laboratory, and the students also have their own computers and cubicles so that they can focus on their work. As far as fabrication laboratory is concerned, we have got various facilities. Like this is the vapor phase CVD machine, which was indigenously developed by my master's and PhD student. Because if you, for the growth of single walled carbon nanotube, because if you really want to grow, develop this kind of procure rather this kind of CVD from multinational market, we need to pay at least 30-40 lakhs. But we got it, developed, designed and developed indigenously for the worth rupees 8 lakh only under one of the CSI project long back in 2006-7. We have got couple of 2-3 CH electrochemical workstation by which you can do we can have 1-dimensional nanostructure, 2-dimensional nanostructure, and 3-dimensional structure as well. As far as the devices are concerned, because since we are working on 1-dimensional nanostructure and we are working on devices, we need the probe station and wire bonder machine as well, which we have with us. This is another view of the fabrication laboratory in which students are working. Whereas the very specific equipments are concerned, we have this Ketley 4200 semiconductor characterization system by which we can characterize 2 terminals in the device. All FETs characterization can be done, and most importantly, this we have integrated with this indigenous.
Sir, not audible. Excuse me. Prashant sir.
Oh, okay.
Please unmute Shirsat sir's phone.
I'm sorry. Oh, I don't know
Yes,
how long I was muted. Fraction of second, okay. Prashant, you please ensure, because sometimes what happens in Zoom, automatically it's going to be muted, right? Okay. So kindly take care of that. Otherwise, people will be missing trend, right? So I would appreciate if we can take care of that. Okay. So I was talking about this Ketley 4200, which we have integrated with this indigenously developed dynamic gas testing setup. As a result of that, we can at a time we can see the performance of 16 sensors. Because I'm going to show you, no, in this presentation I'm not going to show you that, but because we are today I will be talking on heavy metal ion sensor. But as far as gas sensor is concerned, we are having 16 sensor chip. Simultaneously 16 sensor can be recorded here, so that the repeatability and reproducibility, that is one of the very important parameter as far as sensor research is concerned, that is going to take care here with this integration. Then this is another view of fabrication laboratory. This is the device I was talking about, VIS NIR hyperspectral imaging spectrophotometer. This is being used for the surface vegetation. And okay, this is again very unique facility in the university system, because most of the universities, they don't have this kind of system. Microsystem technology laboratory, clean room of 10,000 class. We have invested substantially in this. We got substantial funding for DST Nano Mission, DST SARB, and Russa Center. I mean Rusa as well, Russa Government of Maharashtra. This is mask aligner, which can be used for like pattern transfer as well as any type of devices. Like you can work on LED, FETs, MEMS, names, whatever. Very recently we started working on MEMS. This is EBM thermal evaporator, which is going to be very important for deposition of materials on the various substrates. This is another view of Microsystem Laboratory. Okay, this is one more view. And as far as characterization is concerned, we have got Xray Diffractometer, very sophisticated characterization laboratory, Bruker XRD, D8 advanced system, very advanced, through which we can do powder sample, you can do SAX, you can do PDF, you can do micro diffraction, you can do liquid sample. This is one of the very unique facility. And again, there are very few systems across the country which is having this kind of facilities available. This is another view of the sophisticated characterization facilities. We have got AFM with STM. You can do atomic force microscopy and scanning tunneling microscopy, which is integrated together under this single system. We have FTIR in UV as well. And very recently, we procure Raman's spectrometer as well. Horiba Raman spectrometer and BED surface area analyzer as well under DST. This is under DST fees and this is under DST SRB project. I was talking about prototype devices, right? So far we have developed 3 to 4 prototype devices. For the sake of information, I have mentioned here 2. This is Babasaheb for detection of ammonia, and this is quadra-analyte sensing gazette for detection of 4 different analytes: NS3, CO, SO2, and BTEX. And this is one of the very cost-effective device, because in international market, quadra-analyte sensing gazette, even for like Honeywell, costing around 1,000 USD. Even Chinese product costing around 10,000 to 15,000, but cost of this is only 1,000 rupees. We have already submitted for patent. As far as capacity, because I was talking about capacity building, because for every month we are organizing this kind of program for research scholar, undergraduate student, postgraduate student, and young faculty members as well, like familiarization workshop. What we are doing, we are explaining what kind of facilities we have and what should be the methods for utilization of those facilities. And then we are inviting proposals, short-term and long-term proposals. Proposal means, like, if you are submitting proposal, I'm going to make it sure that you are going to end up with some publication. That's it. And then you will be entitled to use all the facility free of charge. You don't need to pay anything, only consumable you have to pay. And the beauty of this is you will be able to have the access to those state-of-the-art facilities. Wherein, like, most of the time we will only seeing those facilities from distant aid, right? But here you can come down there and make use of the facilities. And then we are providing hands-on training, as I mentioned earlier. To begin with, we are providing hands-on training for shortlisted proposal, and every month we are organizing IPR workshop as well to create some sort of awareness about the IPR facilities. This is website of my university, and here you can see Russa Center. You can click here, you can go further and see what kind of facilities we have, what are the programs available, and what is the modus operandi as well. If you don't want to use facilities in collaboration, then you can pay, because we are using, we are providing services on tariff basis as well. So this is the list of charges we are charging for all the facilities which we have. This is a huge list because we have got many equipment. So we are charging this. So from through this also we have generated substantial revenue during these 4-5 years. So this was all about my center. Now I'm going to introduce you the water pollution and heavy metal ion sensing. Friend, as far as the water pollution is concerned, Prashant, can you please clear the screen? Somebody has scratched down the screen. I don't know who is doing this notorious activity. So kindly make it sure, because otherwise it will not be visible to others. So as far as this environmental pollution is concerned, okay, no problem. I will be moving further. We have got lot of like very challenging situation as on today. Lot of pollutions like air pollution, water pollution, land pollution, noise pollution, thermal, visual, light pollution. Today we are going to take care of, discuss water pollution, to be more precise. I'm going to tell you some of the important facts. Although water covers most of the planet, but just 2% of it is a fresh water. There are many facts, but I'm not going to read all those. Some of the important facts I'm going to read, but you can see and 1 out of 5 don't have access to safe drinking water. This is the problem, global problem. It's not like Indian problem, it's a global problem. As far as Indian concerned, scenario is concerned, more than 100 million people in India live in the areas where we are having a poor quality of water. Like across, you can see, this is the Indian map. So across the country, the most of the, like, even if like I am sure this college is also rural college, and this college might be facing problem of getting like fresh water, and I mean the less contaminated water. As far as water pollution is concerned, there are different sources of water pollutants like organic chemicals, water soluble VOCs, pesticide, heavy metal ions, salts, and etc. But we are going to today speak about the heavy metal ion. Now, what is heavy metal ion? You can see heavy metal ions are generally defined as metals with relatively high densities, atomic weights, and atomic numbers. This is the conventional bookish definition of heavy metal ion. This is the list of various heavy metal ions we are having, and some of them are going to be good for human health. You can see copper, cobalt, chromium, nickel are going to be, if of course up to certain level, and while others are carcinogenic and toxic, affecting our central nervous system. Examples of mercury, lead, arsenic. Some of them affect kidneys and livers, like mercury, lead, cadmium, copper, and some of them can cause skin and some skin related disease issues in both and teeth as well. This is the examples. It means these heavy metal ions can be a boon for us and can be curse for us as well. So we need to be very careful about that. As far as the MCL is concerned, MCL is maximum contaminant level proposed by this has been proposed by United States Environmental Protection Agency, US EPA, United States Environmental Protection Agency, because we need to see like what are the international standards. We call it as a US EPA, and these are some of the MCL levels for all some of the contaminant, water contaminant. This is in mg per liter, different units I have put it down here. And this is the list of some of the essential metals and non-essential metals. Like this is the list of essential metals, this is the list of non-essential metals. As far as the contaminant sites are concerned, these are the different sites in India for chromium, the contaminant sites in India: lead, mercury, arsenic, copper. And let me tell you very specifically, data of Central Pollution Control Board show that Gujarat, Maharashtra, and Andhra Pradesh contribute to 80% of hazardous waste, including heavy metal ion. Means Maharashtra is one of the state in which like 80% of hazardous waste is coming from, including heavy metal ions. So we need to be very careful. That is why we thought we should work on this particular area as well, apart from the VOC sensor, which we are focusing at our center, right? And as far as the effect of that all those heavy metal ions are concerned, you can see almost entire parts of the body are going to be affected with heavy metal ion if you are consuming excessive heavy metal ions through drinking water. Now, if this is the problem, what should be solution? The solution should be very smart. Nowadays we're talking about smart solution, right? So what could be smart solution, that I'm going to explain here. So what essentially we are doing in the heavy metal ion sensor. Now, to begin with, let me tell you, we started with because whatever I'm presenting, most of the work has already been published in various journals since last 2-3 years. So to begin with, I'm going to show you the quick overview of the conducting polymer, synthesis of conducting polymer and ITU coated, and then we went ahead and did electrochemical and electrochromic response, and then that has shown wonderful electrochemical and electrochemical response toward the copper ions in aqueous media. Now you can see here, if you look at this, this is the CV which we have recorded while synthesis. An oxidation peak at 0.3 and 0.6 volt and reduction at 0.45 confirms that we end up with the polyaniline. And then we went ahead and then we have incubated in copper ion. Like you can see, this is the FTIR before and after incubation. So if you look at this FTIR, absorbance as well as transmittance, you will come to know that there is a substantial increase in transmittance after incubation of copper ion. This is what we were expecting, and this we got the results as well. Moreover, from this visible spectra, it's clearly observed that the transparency, transmittance of the film increases whenever we are when after incubation. And moreover, like before, and this is CV before and after incubation, and we got let me tell you, we got wonderful chromic, electrochromic and electrochemical response. You can see the changes color before and after incubation. And later on we tested it for the detection of this is the differential pulse photogram for copper. You can see substance. This is with after incubation, and this is before incubation. Before incubation of copper ion, there was flat curve. We did not observe any peak, but after incubation we could observe very significant peak, right? And this was the this was the experimental setup we have utilized for this study. And this work was published, as I mentioned earlier, this work was published in Sensors and Activators B Chemical long back. Now in these, although we got a good response for conducting polymer, polyaniline for Cu metal ion, but we wanted to enhance sensitivity and selectivity. And for that purpose, we thought, let us have a composite of CNT with organic conducting polymer. And then whenever we are talking about composite, we need to understand what kind of advantages we are going to have, right? Let's say carbon nanotube. What are the advantages aspect? Carbon nanotube has got very high surface to volume ratio, because this is nanostructured material. It has got excellent electrical properties, excellent mechanical properties. However, there are some issues as well as far as the heavy metal ion is concerned. One of the critical issue is the CNTs are hydrophobic in nature. This is going to be one of the problem whenever you are using in aqueous media. And moreover, the pristine CNT lack functional binding. That is also going to be, because if you really want to functionalize the CNTs, there will be some limitations. It's not like you cannot do it, but there will be some limitations. Similarly, organic conductive polymer has some certain advantages and disadvantages. What are the advantages? It has got excellent redox properties and electric charge transfer properties. Ease of synthesis, conductivity can be modulated like anything. And however, although there are some advantages aspect, but there are certain problems as well. What are those problems? You are going to have a mechanical stability is going to be one of the great issue. But if you synthesize organic conducting polymer at nano level, obviously the stability can be enhanced significantly. And moreover, if you are using this for sensor, hysteresis is going to be one of the great headache for organic conducting polymer. However, if you are looking at these two material, if you have the composite of these two material, obviously all those disadvantages aspect can be addressed, and you can tap the advantageous properties of both the materials, and you can go ahead. This is what we have done. This is what we are doing, in fact, in our laboratory. What we are doing, this is, you see here, we are using SDBS as a subtractant. With single walled carbon nanotube, we are doing sonication so that you can have the debundling of the CNTs. And then we are using, we are adding on aniline and dopant, and we are doing stirring of that, right? Once we have the homogeneous solution, then we are moving ahead and doing electrochemical synthesis of this on the desired substrate. It could be platinum, it could be stainless steel, or it could be whatever conducting electrode. Once we have the composite on the substrate, then you can do modification of that with various chelating ligands, because we are using chelating ligands for enhancement of the selectivity as well, right? Selectivity as well as sensitivity. So then by deep coating, we are using, we are modifying the composite structure with chelating ligand. And then for differential pulse voltammetry, for stripping, what we need to do, first of all, we need to accumulate the metal ions. So accumulations are being done again. Accumulation is being done again by dipping the substrate in the solution of given metal ions, and then we are doing electrochemical detection. So this is the protocol of what development of the sensor strip and detection of metal ion in the laboratory. These are some of the the chelating ligands we are using for modification of nanostructure material, this composite material, right? EDTA is one, DMG is another, ADA is third. So these are three different chelating ligands so far we have explored for addressing a selectivity issue. Moreover, while going through literature, and we have seen by doing experiment as well, that if you somehow could manage pH during pre-concentration as well as reduction, then you can be your device can be very selective due to different ions. Let us say Ni. For Ni, if you could manage 2.1 for pre-concentration and 2.2 for reduction, obviously you will be able to fine tune your device to Ni. It will be highly selective. So this is some of the data which we have already explored while doing experiment. So this is another work which we have already published in 2018 Electrochemical Acta. What we have done here, we developed the composite of PPY, polypyrrole, and single walled carbon nanotube, and modify it with EDTA, and we have utilized that for detection of Cu and lead, copper and lead. You can see this is electrochemical CV. This is CVs for bare PPY, and then composite PPY SWNT, and EDTA modified nanostructure material. You can see the clear-cut distinction in CV as well. Similarly, we went ahead and did EIS also, and in EIS studies also, we could get the significant discrimination in all these three different devices, and same thing is true with FTIR as well. So this characterization was done just to have the presence, to understand whether those function groups are there, and whether there is a clear-cut distinction between bare, composite, and modified devices, right? And same thing, we went ahead and did common Raman spectra as well. You can see there is a slight shifts in D and G, both the bands, whenever we modified this nanostructure with EDTA. And then we went ahead and did this photometric behavior for detection of lead. You can see here this was with PPY, RAID was with composite, and you can see this is EDTA modified. It means you can see there is a substantial increase in current, by like for bare PPY you can see the current level, for composite you can see the current level, and for EDTA modified still it is more enhanced current, and then moreover you can see the sharpening in peak as well. And then we went ahead and did the study for this is more a systematic study. This was a one-shot experiment. This was one-shot experiment, and this was a more systematic study. You can see copper, we varied the concentration right from 2 micromolar to 4 millimolar, and you can see the substantial difference, discrimination in various peaks as well. And same thing is true with lead as well. Now, as far as the MCL level is concerned, whenever we are talking about any sensor, whether you need to see like what is the low detection limit, and whether it is reaches to the standard level which we were talking about, right? So this MCL, US EPA talks about this MCL level. So for copper, the MCL level is 1.3, and we could reach 0.49. It means we went well ahead of the MCL. So this is one of the success. But as far as lead is concerned, we could not reach, because MCL lead is 0.015, but we could reach for 0.049 only. So somehow we were not happy with this result. We again did the cross sensitivity study as well, and we got substantial peak only for copper and lead. We could discriminate at metal ions. And then we went ahead and did this is the polyaniline with SWNT. Earlier we did polypyrrole with SWNT. This is polyaniline with SWNT and modified with EDTA again, right? And again we did the same investigation, CV, and then you can see this is EIS study, and then this is FTR spectra. We can have this clear-cut distinction. And then I will be focusing more on sensing result. You can see here copper, we could enhance further. You can see earlier it was some little bit lesser than this, but low detection limit here with this approach, we can see our low detection limit was 0.2 mg, right? And as far as the lead is concerned, we could not get any significant enhancement. PPI composite of PPI with SWNT was better. This was not at all better, right? So this is how we need to understand, right? And then we have also tested the same structure for for detection of mercury also. For mercury, again, although MCL is 0.002 mg per liter, we could reach 0.6 low detection limit. Very close to that, but still it was better than what it was reported at that time in the world. That is why we could publish the data. And then we have also explored. This is with EDA, right? So Pani again polyaniline SWNT with EDA. So we thought like we tried EDTA. Now let us try EDA. So we went ahead and did modify polyaniline SWNT substrate, composite with EDA, and you can see we got wonderful results. Like this is just a confirmation for CV, and then this is FTIR and XRD, the clear-cut discrimination between bare and modified and composite. And then you can see this is Raman spectra as well. This is Pani SWNT, and this is EDTA modified Pani SWNT. There is clear cut distinction. As far as AFM is concerned, you can see after modification there is substantial increasing roughness level. You can see this is from AFM image. You can see the roughness profile. So through this profiler, you can easily conclude that yes, the surface roughness increases because of the chelating ligands, and this is what we were expecting. And then we went ahead and tested it for detection of Ni, nickel, right? And here to our surprise, like MCl level was 0.2, we could reach very close to that 0.5. So although still it was better than reported right data, and so therefore we could publish it in good journal. And then we also explore like what is the effect of SHI irradiation. So what we did, this same structure, polyaniline with SWNT, we have exposed it to SHI irradiation, oxygen ion, and with different fluences, and we investigated this as well. This is the CV while synthesis. This is AFM, and then with different fluences, we can see this is the FTIR and clear cut distinction in FTIR spectrum as well. These are AFM images after SHI exposure of various fluences. You can see if we increase the degree of fluences, you can see the increase in roughness of the film, reference of the nanostructure, and this is what we were expecting. You can see through this height profile also, you will be able to understand that there has been significant increase in roughness, and there similarly from XRD also we got the significant distinction. And this paper was this work was published in Radiation Physics and Chemistry. And then what we did, as I mentioned earlier, we modified the same structure with EDA, right? Sorry, with DMG now, with dimethyl glycosamine. So we thought like let us use another. This paper was published in Material Research Express, and again like this is CV with pristine composite and exposed composite. You can see the difference in CV. Similarly, difference in EI spectra as well, and same thing is true with FTIR too. And similarly, we went because since we were using SHI irradiation, the band gap was very much important for us, and we could engineering band gap was very critical point, and we could optimize the band gap for 1 to the power 10 to the power 10 to the power 10 ions per centimeter square fluence, which was equal to 1.63. And for that purpose, you can see the ACM images as well. There is a significant increase in roughness of the nanostructured material after increasing fluence rate. Now, it was having significant impact on the sensing. You can see before exposure, the low detection limit was 0.12. And whereas after exposure, low radiation limit reduced down to 0.65. It means that SHI irradiation has significant impact on reducing the low radiation limit. And we could reach you can see the MCL level is 0.1 and we could reach 0.1. So that was a happy moment for us. So with this result, what was our achievement? Our achievement was we could selectively detected analytes. We have achieved US EPA level for at least 2 analytes, heavy metal and copper and cobalt. We could not reach the MCL level for others. It was simple electrochemical sweep technique was applied here, and SHI irradiation also give us substantial impact. What are the limitations of this investigation? This approach limitation. With this approach, only laboratory scale tests can be done. But our ultimate target was to come up with the devices. So development of lab on chip type devices, this kind of approach is not going to be useful, and therefore development of miniaturized devices with more stable polymers need to be explored. And we started exploring, and I'm going to tell you what kind of result we got. Now let me tell you, my friend, here we started working on organic field effect transistor for detection of heavy metal, and we got substantial result as well. Now, as far as these results are concerned, organic conducting semiconductors are going to be key building block for all devices, right? Moreover, the solution processability of organic conducting polymer is going to be very, very important. It provides us cost effective and large scale fabrication of OFD, but there are some issues. These are advantages. What are the issues? It has got poor charge mobility, right? This is very important. Charge carried mobility, mu, is very poor as far as conducting polymer is concerned, and therefore we started exploring some other materials. So we thought let us see whether CNT can provide us that bridge the gap. We identified the gap as far as the device is concerned, and we came to know that CNT can be a better material which can address, because CNT can be used as a mu enhancer, because as far as CNT is concerned, it has got wonderful charge carrier mobility, and moreover, the very important thing is CNT in semiconductor polymer acts as a ballistic conduction bridges between the polymers, and as a result of that, conductivity can be substantially increases. Moreover, there are certain polymers which are not going to be stable in aqueous media, like polyaniline, polypyrrole, right? And therefore, what we started thinking some different polymer like P.PSS, right? Because P.PSS has got wonderful stability in aqueous media, right? And therefore, we started exploring P.PSS, and this is the two different configuration we have utilized as far as FET is concerned. One is liquid ion gated FET, and this is bag gated FET. There are two different configuration we have used. And then this is the interdigited electrode we have used, because we talked about the devices. So for devices, you cannot use planar substrate. So this is interdigited electrode we have used for this kind of study. And then this gap can be breached with the P.PSS and conducting polymer and organic conducting polymer composite by electrochemical polymerization. And then you can do IV morphological, structural, and spectroscopic characterization just to confirm. You can expose that with SHI, and again you can do all those characterization to just confirm what are the changes, right? And then you need to see the detection. So I'm going to show you the quick result within 5 minutes. I'm going to summarize now. You can see these are the result we got. This is IV of P.PSS, and you can see P.PSS and P.PSS modified with graphene, reduced graphene. You can see the difference. If P.PSS, we know the conductivity of P.PSS is not good, so you can see the difference in IV. Substantial. After addition of graphene, there is substantial increase. And then we went ahead because we wanted to have a FET. So we wanted to study whether it is going to show us the FET behavior. So as far as FET is concerned, we need to see whether the gate voltage is going to play significant role. For that purpose, you need to study output characteristics as well as input as far as transfer characteristics. So this is the output. B is the output characteristic of P.PSS, and this is the transfer characteristics. You can see the clear-cut on-off ratio and wonderful control of like gate voltage on the flow of current from drain to source. And then we went ahead, and this is this is the output characteristics of RGO, right? Because first of all, we saw the P.PSS, then RGO independently, and then this is the composite output characteristic of P.PSS with RGO, and this is transfer characteristic of P.PSS with RGO. If you look at the current level here, there is a significant increase in current level. Although we got the FET behavior for P.PSS alone, RGO alone, but when we have the composite, we could enhance the substantial current, because that was one of the area of concern, because whenever we are talking about devices, you need to have the substantial measurable current. Otherwise, your power, the power supply is going to be very, very important. For that, it is going to become bulky, and that was our target, and we could achieve that. And then we went ahead and did the sensing study. You can see this is the ID versus VDS of the P.PSS with graphene, and this is what, like, we kept VGS and VDS constant, and we allow this analyte, the concentration of Hg, mercury, to modulate IDS, and you can see that there is a significant difference from 1 microgram per liter to 70 microgram per liter, and you can see the linearity is also significant. So this is what we did, and then we also study the cross sensitivity study also, because we tested this device with various, you can see various metal ions, Fe, Na, Zn, Cu, Pb, and all that, and you can see we got significant response only for cadmium and mercury. So mercury was great, and next to that was cadmium. So that was the wonderful FET device we have developed. And in summary, let me tell you, although we have achieved US EPA level with the first approach which I talked about, but there were some issues, like we can do laboratory level research. But if you really want to go ahead and convert your laboratory research into prototype product, and if you want to come up with the devices, then lab on chip need to be very important. For that purpose, FET detection could be a great idea. And SHI, we also observed that SHI plays significant role in improving sensing behavior as well. So with this, I would like to thank all research scholars, because whatever today I have presented, credit should goes to my research scholars, collaborators, because we have got substantial collaborations at national level, international level, and moreover, we have got substantial funding. I would like to acknowledge my financial supporters as well, which include DST Nano Mission, DST TSD, DST SARB, UGC, CSIR, and then RUSA as well. With this, I would like to stop here.